Okay. So yesterday we started the second chapter. Good afternoon to everybody. So yesterday we discussed, we started the second chapter, that is second chapter name is process. And under that we started the first point from this chapter, that is process concept, right? And under process concept, we discussed about the definition of process. And then we discussed about the difference between process and program. So program, it is the big entity, it is the passive entity, and process, it is the active entity which is going on at that moment. So process is the active entity and program is the passive entity. And further, with respect to storage and other resources, so program requires only the storage, but process requires other resources like CPU, input output devices, etc. So like that, further we discussed process in terms of its contents. So process consists of three sections: text section, data section, and stack section. Then we discussed about the concept of process state, right? So we discussed about concept of process state. So what is state? Can anybody? Process state. What is the technical definition of process state? Anybody? Yes.
Current activity of process.
Good. It's the current activity of the process. It is also defined as a lifetime of process divided into number of stages. It is also defined as lifetime of process divided into number of stages, and each stage is called as a state. So like that, in case of our operating system process, so it is having total five states generally applicable with each and every operating system. So first state is the new, that is process is being created. Second, running, instructions are being executed, waiting, the process is waiting for some event to occur, mostly the input output event. Ready, the process is waiting to be assigned to a processor. So it is ready, it has acquired all the resources except the processor, and once the processor will be assigned to it, so it will be going to change the state from ready to running. And terminated, that is it has finished everything execution, now it want to terminate normally, so it is called as a terminated. The process has finished execution. And accordingly we discussed about the process state transition diagram. So this is the diagram of process state. So it is also called as a process state transition. So again, these are the five states applicable generally to each and every operating system. Further, if we take particular operating system, so these five states maybe get converted into 9, 10, 11 like that. So according to OS, number of states will be different, but basically these are the five states which are present in each and every operating system. Okay, so yesterday we discussed with the help of example also, we taken few examples in the real life, and how the state transition occurs from new to ready, ready to running, running to terminated, or running to waiting, waiting to ready, ready to running, like that onwards. So now we'll proceed further to the third sub-concepts under process concept. So third point under process concept is PCB, process control block. PCB, process control block. So mostly again MCQ type question will be asked on this particular word. So PCB stands for, is it process control block or program control block or processor control block, like that, etc. So it is the process control block. So each process is having its own PCB internally in the operating system. Whenever process will be get created, so each process is having its own PCB, process control block. So it is the you may say that it is the representation of process internally by the operating system. So we are saying that, from yesterday we are saying that it is the process, it is the process. So can I see the process? No. So it is not possible for me as a user to see the process, but process is represented internally with the help of PCB. So operating system maintains the process with the help of PCB, process control block. So we'll see what are the fields of this PCB. So information associated with each process, it is also called as a task control block. So this PCB, process control block, is also called as a task control block. So process is also called as a task. So it is information is associated with each process. So each process is having its own PCB. जर माझ्या सिस्टीम मध्ये 10 प्रोसेसेस असतील तर 10 PCB असतील. So like that, whenever processes get created in the system with the help of fork system call, immediately one table is assigned to that process. So actually again it is the kind of data structure, it is the storage, it maintains the information about the process. It maintains the information about the process. So what kind of information it maintains, we'll see in detail. So it consists of, this PCB consists of process state. So as just now we discussed, so each process, it goes through 5 different states. प्रत्येक process ह्या 5 state मधून pass होते. So for some time it may be in the new state, for next time, for next maybe 5 minutes or 5 seconds, it may be in the ready state. To the next 5 to 10 seconds, it may be in the running state. Or it may go to the terminated state. So that is at each and every moment. So if once we start the process, so process changes the state from one state to another state. So operating system, it's the work of operating system to maintain the state of the process. So currently in which state process is, currently in which state process is, and that is stored with the help of first field of PCB, that is process state. So either running state will be there, either waiting state will be there, or ready state will be there, new state will be there, terminated state will be there, etc., etc. So whatever 5 states are there, so either state is preserved under this field process state. And normally internally, actually I said that this is the process control block, and this is the block created by the operating system. हा block तयार कोण करतो? Operating system. केव्हा? Whenever process will be get created, जेव्हा process तयार होते, प्रोसेस तयार झाल्या त्या प्रोसेसला एक PCB असाइन केला जातो इंटरनली. आणि थोडक्यात PCB म्हणजे काय? हा एक ब्लॉक आहे. सो इन टर्न इट इज द मेमरी, and what it stores this much amount of data. So these many fields are stored inside that block. So the first field is state. So in the state field, either the state will be new or running or waiting or terminated or ready, etc. At a time सगळ्या स्टेट असू शकत नाहीत. एका वेळेस एकाच स्टेट मध्ये प्रोसेस असते. So that's why I'm giving trust to this. At a time in this field only one state will be there. Either it will be new or it will be running, it will be ready, or it will be terminated, or it will be waiting. Right? So either state is preserved over here, and this field is changing throughout the lifetime of the process. हे जर फील्ड आपण बघितलं तर हे कॉन्स्टंट राहणार नाहीये. जोपर्यंत जेव्हा प्रोसेस क्रिएट होते तोपर्यंत ती टर्मिनेट होत नाही, तोपर्यंत हा फील्ड व्हॅरी होत राहणार आहे. इट इज व्हेरिएबल throughout the lifetime of the process. So right, next, so second field, that is program counter, location of instruction to next executable instruction. Right, so yesterday we discussed what is program counter. It is a special purpose register of the processor which stores the address of the next instruction. And again yesterday we seen that one process, we defined process as a set of instructions. So one process may consist of more than one instructions. एका प्रोसेस मध्ये किती इन्स्ट्रक्शन असू शकतात? एकापेक्षा जास्त इन्स्ट्रक्शन. So again yesterday we taken the example, process P1 is having 4 instructions and we given the names I1, I2, I3, I4. So if process P1 is having 4 instructions, so if I want to start this process execution, so my program counter should have the address of I1, that is instruction 1. If I started the execution of instruction 1, so my program counter should consist of the address of the second instruction, I2. So that is nothing but the program counter. So again, this program counter field is also variable throughout the lifetime of the process, because process consists of number of instructions. If process consists of 10 instructions, so 10 times this counter will be validated. That is per instruction. Whenever it is moving from first instruction to the next instruction, so it is trying to store the address of the next instruction. Right? Whenever it is going from second instruction to third instruction, so it should store the address of the third instruction. Whenever it is going from third instruction to fourth instruction, again it should store the address of the fourth instruction. So like that, again this program counter field is also variable throughout the lifetime of the process. It depends upon the size of process. So size measured in terms of number of instructions, right? So there may be 100 instructions, there may be 10 instructions, there may be 4 instructions, depending upon the size of process. Next, CPU registers contains contents of all process centric registers. So normally CPU registers, if we consider, so depending upon the processor, different types of registers are there, like A, B, C, D, H, L. So mostly applicable with respect to 8085 processor. So instruction registers are there, and these register pairs are also there, A, B, C, D, and H, L. So like that, so some CPU registers are also required. The most important register, that is nothing but the accumulator. So accumulator is also required to perform the arithmetic operations. So all these registers are also stored as a part of this PCB. So this PCB, as I said, that PCB per process, one PCB is there. So one process may utilize all the registers, or one process may utilize 2 registers. So whatever number of registers are used, so the data about these registers is maintained with the help of this field. Next, CPU scheduling information. So as in the system more than one processes are going on at a time. एका सिस्टीम मध्ये, एक ऑपरेटिंग सिस्टीम मध्ये आपण जर 5 किंवा 6 प्रोसेसेस स्टार्ट केल्या, so again it depends upon the priority of the process. So which process should be executed first, which should be executed next, which should be executed last. So that is nothing but the scheduling. So scheduling, CPU scheduling information, that is what is the priority of that process. Is it the first priority, second priority, third priority? So that priority should be maintained somewhere. So that is maintained as a part of CPU scheduling information. Scheduling queue pointers. So actually again in the next point in the same chapter, that is process scheduling. So we're discussing about scheduling queues. So different types of queues are there, and processes are moving through these queues. So again, as this is the PCB related to one process, so we should have the data about scheduling queue. So in which scheduling queue this process is residing, so that address should be, or the pointer of that scheduling queue should be there in this PCB, because this PCB is giving information about that process. So whichever process will be there, so we should identify in which queue that process is there. So 3 queues are there: ready queue, job queue, ready queue, and scheduling queue. So like that, 3 different queues are there. So in either queue the process will be residing. So pointer or the address of that queue should be maintained as a part of this PCB. Am I audible, students? Yes.
Yes, ma'am.
Okay. So next, that is memory management information. So again in this PCB, it stores the information about the memory, how much space is acquired by this process. So as this is the process, this is the data about the process. So how much, what is the size of that process? What is the size of that process? Which partition is allocated to that process? Which space is allocated? What is the starting address of that process? What is the ending address of that process? Right? So if this is the memory, if you assume this particular block as a memory, and if my process is residing over here, so this will be the start address of this process, and this will be the end address of that process. So process is stored. So process requires some memory. So that information should be maintained as a part of PCB, memory management information, memory allocated to the process. Next, accounting information. So accounting information, like you people, so you are the student of SVERI. So your record is also maintained at a department level, and your record is also maintained at office level, right? तुमच्या सेपरेट फाइल्स तयार केलेल्या आहेत ऑफिस मध्ये, आपल्या कॉलेजच्या ऑफिस मध्ये. So some accounting information is required to be maintained with the system. Some accounting information is required to maintain in the system. And what do you mean? What do you mean by accounting information with respect to process? That is CPU used. So how much amount of time this process has executed on the processor? So whatever process, whatever data we are storing, with respect to whichever process we are storing the data. So operating system should maintain the time used by that process on the processor. So how much time it has executed on the CPU. So that is nothing but one of the accounting information. Next, clock time elapsed since start and end time limits. So that is at what time the process has started and at what time it has terminated. So again, these two times are recorded. So this is also treated as a accounting information, right? So like you people as a student, so some data is maintained as a part of department and some data is maintained, some other data is maintained as a part of office. ऑफिस मध्ये जे रेकॉर्ड ठेवलेले आहेत तुमचे ते डिपार्टमेंटला लागत नाहीत किंवा डिपार्टमेंटला ठेवलेले जे रेकॉर्ड आहेत ते ऑफिसला लागत नाहीत. दॅट्स वाय सेपरेट डेटा वी आर मेंटेनिंग, बट you are the single entity, you are acting as a process and your data is maintained in the system. So college itself acts as a system and system required to maintain that data. Though you get passed out, तुम्ही जरी पास आउट झालात तरी पण तुमचा डेटा कॉलेजमध्ये मेंटेन केला जातो. मे बी सपोज असं अजून करा की तुम्ही पास आउट झालेला आहात आणि एक 10 वर्षानंतर तुम्हाला कॉलेजमध्ये यायचं आणि एखादं डॉक्युमेंट काढायचं, स्टील यू आर गेटिंग द रेकॉर्ड बिकॉज इट इज द वर्क ऑफ द सिस्टम. इन द सेम फॅशन, सो प्रोसेस is created in the system, it is created by the operating system, so it's the responsibility of the operating system to maintain the data about that process, to maintain the data about that process. So data about that process is maintained by the operating system in the form of PCB. So each process is having its own process control block. Next, last data maintained by the operating system with respect to process as a part of PCB is IO status information. That is, which input output devices are activated or used by this process, allocated to process, list of open files. So as yesterday I said that each and every process requires minimum 3 files to execute. First file is called as a standard input file, from where it takes the input for processing purpose. Second file is the standard output file. So after processing the data, so it gives some kind of output and that output is stored in the standard output file. And third file is the standard error file. So during some processes, काही प्रोसेसेस असे असतात ज्या वेळेस आउटपुट तयार होत नाही बट एरर इज गेट क्रिएटेड. So due to maybe some file is get corrected and corrupted, and due to which that process is unable to complete. So in such cases it records the error. So what type of error is occurred and due to which process is unable to execute. So such errors are stored in the error file. So that's why each and every process requires minimum 3 files to access, called as a standard input, standard output and standard error file. Standard input file, standard output file and standard error file. So minimum 3 files should be opened before starting the execution of the process. It is the work of operating system. जेव्हा ऑपरेटिंग सिस्टीमला एखादी प्रोसेस तयार करायची असते तर प्रोसेस तयार केल्या केल्या ऑपरेटिंग सिस्टीम काय करते, 3 फाईल अलोकेट करते आणि ह्या तिन्ही फाईल ओपन करून ठेवते. बिकॉज इनपुट फाईल मधून प्रोसेसला इनपुट घ्यायचं असतं, आउटपुट फाईल मध्ये आउटपुट राईट करायचं असतं आणि स्टँडर्ड एरर फाईल मध्ये एरर राईट करायचे असते. सो दॅट्स वाय दीज 3 फाईल्स शुड बी ओपन्ड. फक्त असून चालत नाही तर त्या ओपन करून ठेवायला लागतात. So these 3 files should be opened by the operating system for that process, and then only the process execution will be get started. So this data is maintained as a part of IO status information, right? So actually here, so the fields are process state, which we discussed here, process number. So whenever any processes get created in the system, in the operating system, so each process is given one unique ID that is called as a PID, process identification number, and that process identification number is called as a process number, like you people. So whenever you will be get admitted to the class, जेव्हा तुम्ही एखाद्या क्लास मध्ये ऍडमिट होता तेव्हा तुम्हाला रोल नंबर दिला जातो, विच इज टोटली युनिक, राईट. तुमचा रोल नंबर परत दुसऱ्या कोणाला रिपीट केला जात नाही. सो इट इज द युनिक, इट इज द प्रायमरी की युज्ड to access you people or to access your record. In the same fashion, in the operating system, to access the process, so operating system assigns unique number to the each and every process, and that number is called as a process number. In another word, in technical word, it is called as a PID, process identification number. This is the process number. Third one is the program counter. So each process requires program counter because each process consists of set of instructions, and to execute these instructions, so program counter is required to store the address of the next instruction. Registers, each process requires minimum one register or maximum more than one registers. So all these registers records are also stored as part of PCB. Memory limits, so that is what is the size of that process, what amount of memory is required to store that process. So that is called as a memory limits. So that is the lower limit and upper limit. So if this is the partition, and if I say that this is address say 200, and if I say that this is the address 300, so I may say that size of the process will be 100. So base address, that is start address, is 200 and end address is 300. So this is called as a limit. Ite lakshat? So here I'm just taking the help of the same block. So whichever block I have shown with the help of registers. So here I say that this is the start address and this is the end address. So address ranges from 200 to 300. 200 indicates start address of that process and 300 indicates end address of that process. So this is called as a memory limits. Limit, lower limit and upper limit. ज्या काही स्पेस मध्ये त्या प्रोसेसला ठेवलं गेलेलं आहे त्या प्रोसेसची लोअर लिमिट आणि अप्पर लिमिट. So this is called as a memory limits. And the next one is the list of open files, which I just discussed over here. And these are the three dots related to memory management information, accounting information, and IO status information. So these three dots are related to these three fields: memory management information, accounting information, and IO status information. So this is about PCB, process control block. Just we'll see. Okay. This is about process control block. So each process is having its own PCB. Each process is having its own PCB. Any doubt, students? Yes, students, are you listening to me?
Yes, ma'am.
Yes,
Yes.
Any doubt? I said that each process is having separate PCB. Keep in mind. जर सिस्टीम मध्ये 10 प्रोसेसेस असतील तर 10 PCB असतात. And these are linked with each other according to the priority of that process. So if I take the priority P1, P2, P3 up to P10, so P1, after completion of P1, so the pointer is pointing to the P2, that is after completion of process P1, so it should go to the process P2. So it executes process P2, and again from process P2 the pointer will be assigned to P3, like that onwards. So these are linked. So these PCBs are linked. So these are connected with each other. It depends upon the priority of the process. Okay. So if you are having any doubt, you can ask. Otherwise, you can note down this point. So this is the sub point under process concept. This is the sub point under process concept. Write down. If you are having any doubts, you can ask to me. Process control block. Draw the diagram. If anybody is having doubt, they can ask me. Yes, is it over, students? Yes, is it over? Yes, students, am I audible?
Yes, ma'am.
So can we proceed further?
Yes, ma'am. Yes.
Okay. So we'll move to the next point. So next point, that is the last point from the process concept, that is context switch. So CPU switch from process to process. So it is called as a context switch. So the point is context switch. So switching processor from one process to another process, and that we are discussing with the help of one example. So over here, if you are looking to this diagram, so process P1 is under execution. So at this moment, okay, so at on y-axis, you may assume that this is the time. So at here, so arrow is shown over here. So initially process P0 is under execution. So from during this period, P0 is under execution, and at this moment, P1 entered in the system, and this P1 is nothing but the interrupt or system call. Okay, so this is the operating system function. This is process P0, this is process P1. So P1 is treated as a either interrupt or system call. So whenever user process was going on, user process P0 was going on, and unfortunately high priority process called as an interrupt or system call occurs. So what operating system does? So operating system switches the processor from lower priority process to higher priority process. So in this example, lower priority process is nothing but process P0, and higher priority process is nothing but interrupt, and over here interrupt or system call, it is shown with the help of process P1, right? So whenever any higher priority process comes, so operating system switches the processor from lower priority process to higher priority process, that is from P0 to P1. So while it is switching processor from lower priority process to higher priority process, so switching processor from one process to another process, it is called as a context switch. It is called as a context switch. So what it does exactly, what is the work of operating system during context switch? So it saves the current state of P0 on PCB0. It saves the state into PCB0. Actually process P0 कंप्लीट झालेली नाहीये, त्याचा काही पार्ट एक्झिक्यूट झालेला आहे, आणि अनफॉर्च्युनेटली त्याची प्रायोरिटी कमी असल्यामुळं हायर प्रायोरिटी प्रोसेस आल्यामुळं प्रोसेसर त्या प्रोसेस कडून लोअर प्रायोरिटी प्रोसेस कडून हायर प्रायोरिटी प्रोसेसला स्विच होतोय, right? So that's why it is the work of operating system to save the state into PCB0. So state is not only the state that is the process states. So it is related to all the information related to PCB. So it saves the data on the PCB0 with respect to P0. It reloads the state from PCB1. So PCB1 stands for process control block for process P1. So it reloads the state from process P1. So for this amount of time, that is during this amount of time, process P1 may be idle, and whenever the data of P1 will be loaded on PCB1, so the execution of PCB1 will be going to be started. So at this moment, execution of P1 will be started. So P1 will be under execution, and once the P1 will be over, so again the state on PCB1 will be saved. फॉर एक्झाम्पल, आता इथे जर पीसीबीचा एक फील्ड घेतला तुम्ही, आताच आपण पीसीबी डिस्कस केला, त्याच्यातला पहिला फील्ड आहे प्रोसेस स्टेट. जर ह्या मोमेंटला प्रोसेस P1 जस्ट क्रिएट झाली असेल, तर त्याच्या स्टेट फील्ड मध्ये काय स्टोअर केलं जाणार? न्यू, दॅट इज न्यू स्टेट. अँड आफ्टर एक्झिक्युशन process P1 will be going to the last state, that is terminated state. So over here the state field will be terminated, right? So over here different data is maintained, and over here different data is maintained. So this is the data after completion of the process P1, and this is the data at the start of the process P1. So reload state from PCB1. execute P1 and again save the state into PCB1. So in between, unfortunately, though P1 is going on, असं assume करा की P0 चालू होती, पण P0 ची प्रायोरिटी कमी असल्यामुळं P1 ची प्रायोरिटी हायर असल्यामुळं जास्त असल्यामुळं प्रोसेसर P0 कडून P1 ला गेला. आता P1 एक्झिक्युशन मध्ये आहे आणि P1 एक्झिक्युशन मध्ये असताना जर सपोज अजून एक प्रोसेस एंटर झाली सिस्टीम मध्ये ज्याची प्रायोरिटी P1 पेक्षा पण ग्रेटर आहे. So in that case, again processor will be switched from P1 to P2. So like that, here the name is written interrupt or system call. Any higher priority interrupt may come, any higher priority system call may comes. So again context switch may occurs. Like that. So it saves the state on PCB1 and again reloads state from PCB0. इथं आपण काय केलं होतं, प्रोसेस P0 थांबवली होती का तर त्याची प्रायोरिटी कमी होती आणि P1 ची हायर असल्यामुळे P1 एक्झिक्यूट केली. So after execution of P1, again it is the work of operating system go to the lower priority process which has we have stopped. So again it goes to the lower priority process. It reloads state from process P0 on PCB0 and again starts execution. So that's why over here the name is written as executing. Over here it is written executing. But during this time period, so process P0 was just idle. It was waiting for the processor. And during this ideal period, processor is grabbed or acquired by process P1 due to higher priority. So that's why P1 will be under execution during this period, right? So this is about the concept of context switch. So the context switch is applicable when system consists of more than one processes. I will take the simple example to understand you people. Assume that we'll take your own example. Assume that my lecture is going on your class. So you are attending my lecture and unfortunately some urgent work is there and somebody called me. So what I need to do? The situation is that I have to stop my current task and I have to switch to that urgent work, whichever is assigned to me, right? So what I will do? So that is your process will be get interrupted. So because whichever second task is allocated to me, so that is treated as a higher priority task according to me. Maybe that task is assigned by principal. So what I will do? So I will stop your process. So what I done? So I means I'm acting as a processor. So initially I was allocated to you people, and unfortunately due to higher priority process, I will get allocated to another task. So this is called as context switch. So I get switched from your lecture to other task. So this is called as a context switch. Or you may say that assume करा की तुम्ही एखादं काम करताय, कुठलंही जनरल एनी वर्क यू कॅन कन्सिडर. एखादं महत्वाचं काम करताय आणि त्यावेळेस अजून एखादं महत्वाचं काम आलेलं, तर तुम्ही काय कराल? तुम्ही प्रायोरिटी डिसाइड कराल, बाबा सध्या करत असलेलं काम महत्वाचं आहे का दुसरं काम महत्वाचं आहे. सो अकॉर्डिंगली यू विल डिसाइड द प्रायोरिटी अँड व्हॉट यू विल डू, you will switch from the lower priority process to the higher priority process, right? So accordingly the switching will be going on. It is also applicable in our real life. So for example असं अज्यूम करा की तुम्हाला एक 3 सब्जेक्टचे असाइनमेंट दिलेले आहेत, OS चे असाइनमेंट दिलेले आहेत, SP चे असाइनमेंट दिलेले आहेत आणि JP चे असाइनमेंट दिलेले आहेत. OS चे असाइनमेंट फॉर एक्झाम्पल मी तुम्हाला म्हटलेले मी आजच दिलेले आहेत, 3 सब्जेक्टचे आजच दिलेले आहेत, पण मी म्हटले की माझी असाइनमेंट 8 दिवसांमध्ये कंप्लीट करा. SP च्या मॅडमनी म्हटले की माझी असाइनमेंट 2 दिवसात कंप्लीट करा आणि JP च्या मॅडमनी म्हटले की माझी असाइनमेंट आजच्या आज कंप्लीट करा. So all these are the tasks assigned to you. So what you will do? Can you tell me? Come on. Yes, students. Hello, am I audible?
Yes, ma'am.
So I have kept one example in front of you. So assume that today only 3 assignments are given to you. OS च्या मॅडमने दिलेली आहे, JP च्या मॅडमने दिलेली आहे आणि SP च्या मॅडमने तुम्हाला असाइनमेंट दिलेली आहे. एक एक असाइनमेंट दिली असं अज्यूम करा आणि असं अज्यूम करा की तुमचे लेक्चर संपलेले आहेत आजचे आणि तुम्ही असाइनमेंट राईट करायला घेतलेला. फॉर एक्झाम्पल मे बी तुम्ही OS ची असाइनमेंट घेतली आहे लिहायला तुम्ही लिहायला सुरुवात केली आहे आणि तुमच्या लक्षात आलं की आपल्याला जेपीची असाइनमेंट आज सबमिट करायचंय, तर तुम्ही काय कराल? व्हॉट यू विल डू? कम ऑन.
We will prioritize JP first.
So you will give the priority to JP because JP you have to submit today itself. So what you have done? So actually you have started writing of OS assignment, but you came to know that then OS we have to give the priority to JP. So you will switch from OS assignment to JP assignment, and you will complete JP assignment, and again you will come back to OS assignment, right? So again you are writing OS assignment again, maybe tomorrow you will click that then OS assignment, because within 8 days we have to submit the OS assignment. So then OS again, SP is most important because within 3 days we have to submit the SP assignment. So again you will switch to the SP assignment, you will complete the SP assignment, again you will come back to the OS assignment. So this is nothing but depending upon the priority of the process. So we are doing the context switch. So what do you mean by context switch? Switching the processor from one process to another process. Instead of calling one process to another process, switching the processor from lower priority process to higher priority process, completing the higher priority process and coming back to the lower priority process. So this is called as a context switch. It is also called as a CPU switch. Got it? And during this switch, during this context switch, so operating system have to do these 4 operations, and these 4 operations are nothing but saving and reloading. So save the state on lower priority process PCB, reload the state from the new PCB, again save the state on the new PCB and reload the state from the previous PCB. Right? So these are the 4 steps. So 2 is important steps followed by operating system during context switch, that is saving and reloading. So saving the data onto the process control block and reloading the data from process control block. Reloading in the sense acquiring the status of that PCB from the memory and again deciding whether to keep it inside the main memory or not. Okay, so this is about context switch. So this is the part which we discussed about in process control block only. Okay, so this is the sub point of PCB. So note down it. Any doubt about CPU switch? Any doubt about context switch? What happened? Nobody is responding today. Yes, students.
No, ma'am.
If anybody is having doubt, they can ask.
No, ma'am, no.
Okay, so then draw the diagram. So you can write the over here the point context switch. Context switch. It is also called as a CPU switch. Context switch. Draw the diagram carefully. This is the most important diagram. So actually you require this diagram in the next semester also. In the system programming also you require this diagram. So carefully draw the diagram. Over. Yes, students, is it over? Yes, students, is it over?
Yes, ma'am.
Other students, are you listening? Okay. So we discussed about total points under process concept. So we discussed the first point, that is process concept. Under process concept, we discussed first point, that is definition of process. And then we discussed about the difference between process and program. Then we discussed the concept of process state. Then we discussed the concept of PCB, process control block. And at last we discussed the concept of context switch. So these many points we discussed under the point process concept. Okay, so now we'll proceed further to the second point of this chapter, that is process scheduling. So under process scheduling, so just let me check. Okay, so actually throughout the third chapter we are discussing about the process scheduling. So actually in the third chapter we are discussing about the different types of scheduling algorithms, etc. So over here, just overview, we are discussing about process scheduling. So it is the process of scheduling the processes. That is, what in the scheduling, so we need to prepare a sequence in which we need to execute the processes. For example, with me, 5 processes are there: P1, P2, P3, P4, P5. So in which sequence I will execute? If I execute P1, P2, P3, P4, P5, this is my sequence of scheduling. Or I may schedule it like P1, P5, P2, P4, P3. So this is the sequence. So deciding this sequence is called as a scheduling. So different criterias are there based upon which we are performing the scheduling. So some OS, some of the operating systems, they are considering the time required to execute the process. So accordingly, different scheduling algorithms are there, like FCFS, first come first served, G process pailanda yield, pailanda schedule oil, like that, or SJF, shortage job first, that is the process which requires less time, that will be executed first. Again, the RR scheduling, round robin scheduling, so assigning each process equal amount of time according to RR scheduling, SJF, shortage job first, priority scheduling. So these are the different types of scheduling algorithms which we are going to discuss as a part of third chapter. So this is nothing but the process scheduling. So scheduling nothing but deciding the sequence of processes. So maximize CPU use, quickly switch processes onto CPU for time sharing. So we have to utilize the CPU properly. We have to do the maximum utilization of the CPU. We should not keep CPU idle. We should keep CPU busy always. And during keeping the CPU busy, so we need to switch the CPU from one process to another process also. So that is the context switch. So process scheduler selects among available processes for next execution on CPU. So it is the work of the job of process scheduling is done by the scheduler. So what is scheduler? It is the operating system program. So operating system itself, it is the program, it is the big program, and it consists of smaller programs. And one of the smaller program is called as a scheduler. So scheduler work is to do the scheduling. Scheduler's work is to do the scheduling. So what is scheduler? Scheduler is the operating system module responsible to do the scheduling. Scheduler काय? एक छोटासा प्रोग्राम आहे ओएस मधला, त्याचं काम काय? शेड्यूल करायचं. What done by scheduling? Deciding the sequence. How to decide the sequence? So for that purpose, again we are taking the help of algorithm. So process scheduler selects among available processes for next execution on CPU. So scheduler selects or chooses the process which is required to run on the processor. So maintains scheduling queues of processes. So this scheduler takes the help of queues. So these queues are nothing but job queue, ready queue, and device queue. So three types of queues are there in case of operating system. All the jobs or all incoming jobs in the system are kept inside the job queue first. So set of all processes in the system. Ready queue, set of all processes residing in main memory, ready and waiting to execute. रेडी क्यू मध्ये कुठल्या प्रोसेसेस ठेवले जातात? ज्या प्रोसेसेस रेडी आहेत. रेडी म्हणजे काय? त्यांनी सगळे रिसोर्सेस अक्वायर केलेले आहेत, सगळे रिसोर्सेस घेतलेले आहेत स्वतःकडे, फक्त ते आता प्रोसेसरसाठी वेट करतायत. सो सच प्रोसेसेस आर केप्ट इनसाइड द रेडी क्यू. इनिशियली म्हणजे सगळे ज्या प्रोसेसेस एंटर केलेल्या आहेत सिस्टीम मध्ये त्या सगळ्या प्रोसेसेस पहिल्यांदा जॉब क्यू मध्ये ठेवल्या जातात. मग त्या जॉब क्यू मध्ये काही प्रोसेसेस सगळे रिसोर्सेस अक्वायर करायचा प्रयत्न करतात आणि त्या रेडी मध्ये जायचा प्रयत्न करतात. सो दिस processes will be switched from job queue to the ready queue. And device queue, it is the set of processes waiting for an IO device. So there may be number of processes which who want to do the input output operation. That is, they want to go to the waiting state according to our process state transition diagram. So such processes are kept inside the device queue. The best example of device queue is nothing but the buffer of a printer. जर तुम्ही कधी प्रिंट आउट काढला असेल तर प्रिंटरचं एक बफर इथं आपल्याला दिसतं आणि त्या बफर मध्ये आपण जेवढ्या प्रिंट कमांड दिलेल्या असतात त्या सगळ्या स्टोअर केलेल्या असतात किंवा त्या दिसतात. आणि त्यातली एखादी कमांड आपल्याला कॅन्सल करायची असेल तर आपण कॅन्सल करू शकतो. सो दॅट इज नथिंग बट दीज आर द प्रोसेसेस दोज हू आर वेटिंग फॉर द प्रिंटर. ते जे काही डॉक्युमेंट प्रिंटिंग आपण प्रिंट करायला दिलेलं असतं. सो ऑल दीज प्रिंट कमांड्स आर प्रेझेंट इन द queue. So that is called as a printer queue. So each device is having its own queue, and there may be processes those who are waiting for that particular device. So such processes are kept inside the device queue. So how many device queues will be there? Each device is having separate queue. So like that, three types of queues are there: job queue, ready queue, device queue. जेवढ्या काही प्रोसेसेस सिस्टीम मध्ये एंटर करतात त्या सगळ्या पहिल्यांदा जॉब क्यू मध्ये ठेवल्या जातात. त्यातल्या काही प्रोसेसेस रेडी होतात म्हणजे काय करतात? त्यांना लागणारे सगळे रिसोर्सेस घेतात त्यांच्याकडे किंवा अक्वायर करायचा प्रयत्न करतात. अँड देन दे आर ट्राइंग टू अक्वायर द प्रोसेसर. एम आय ऑडिबल स्टुडंट्स? हॅलो?
Yes, ma'am.
Okay. So they are trying to acquire all the resources and accept the processor. They are waiting for the processor. So such processes will be kept inside the ready queue, and some processes maybe there are in the system who are waiting for particular device. So accordingly, separate device queues will be there, and in that queue, some processes will be waiting for that particular device. So like that, three types of devices are there in which the processes are residing, and then they are going, then these processes will be getting the processor for execution, and once they got the processor for execution, they will be executed, and then they are going for termination. So this is the concept of scheduling queue. So the concept of scheduler is there. So what is the work of scheduler? So work of scheduler is scheduling. Further, scheduler takes the help of these three queues, and then come to the part of actual queues. So here some queues they have shown. So for example, ready queue. So if you are looking to the ready queue, so here the queue header is shown over here. So head, it is pointing to PCB 7. From PCB 7 it is pointing to PCB 2, and again this queue is ended over here. So after PCB2, again it is pointing to the tail. So tail is pointing to PCB2 and head is pointing to PCB7. So that is in this queue, in this ready queue, only two processes are there. Which two processes? PCB7 and PCB2. So there may be more than two. जर 5 असतील तर 5 PCB असतील आणि पहिल्या PCB ला हेड पॉइंट करत असणार आहे आणि लास्टच्या PCB ला टेल पॉइंट करत असणार आहे. So as this is the queue, so you are good familiar with the data structure queue. So queue is having its head and tail. So it's the ready queue. So in the ready queue, there may be more than one processes, because there may be more than one processes who are ready, who are in the ready state. Next, here they are given magnetic tape unit 0. So this is one of the type of device which was present in earlier days. So tape drive. Nowadays we are using pen drives, but in earlier days they were using the magnetic tape drives. On the tape the data was recorded, stored. So this is treated as one of the device. So its device is shown. So another unit of magnetic tape. So it is another having another queue. Disk unit. So disk is having its own queue. So there may be number of processes which are waiting for the disk. Disk मधून काय करतात processes? So processes, they are trying to access the data. Either they want to read the data from the disk or they want to store the data on the disk. So like that, here in this example, three processes are given, that is PCB3, PCB14 and PCB6. So these are the three processes, those who are waiting for the disk unit 0. Next, another device they are given, that is terminal unit. So it is in this terminal unit, only one process is waiting for this terminal unit for to do the input output operation. So like that, each and every device is having, so all these four are device queues, and this is the ready queue. And almost all these processes are kept inside the job queue. So job queue, it is the first queue. So whatever processes are coming in the system, so all are entered in the job queue, and from the job queue they are going further either to the ready queue or to the device queue. So this is the structure of ready queue and various IO device queues, which we have shown over here. Next, under process scheduling. So this is the diagram with respect to the scheduler. So from the job queue, actually by default over here job queue will be there. So from the job queue the processes are coming to the ready queue, and from the ready queue only one process will be going on to the CPU. रेडी क्यू मध्ये एकापेक्षा जास्त प्रोसेसेस असू शकतात, आणि त्या फॉर एक्झाम्पल 10 प्रोसेसेस असतील तर त्यातली एक प्रोसेस सीपीयू कडे जाते, बिकॉज ऍट अ टाइम ऑन दिस प्रोसेसर only one process will be under execution. So that's why from the ready queue one process will be going to the CPU. So from CPU it goes for termination, or that process may request for IO or time slice expired. So again that is if it is the time sharing operating system. So after completion of the time slice, again it goes to the ready state. Right? If you are able to recall the concept of time sharing. टाइम शेअरिंग मध्ये आपण एक एक्झाम्पल घेतलं होतं, 3 प्रोसेसेस घेतल्या होत्या. पहिल्या प्रोसेसला 30 मिनिट लागणार होते, दुसऱ्या प्रोसेसला 10 मिनिट आणि तिसऱ्या प्रोसेसला 5 मिनिट. जर मी टाइम शेअरिंग अप्लाय केलं तर पहिल्या प्रोसेसला तो 5 मिनिट देतो, दुसऱ्या प्रोसेसला 5 देतो आणि तिसऱ्या प्रोसेसला 5 देतो. परत पुढचे 5 पहिल्या प्रोसेसला, त्याच्या पुढचे 5 दुसऱ्या प्रोसेसला, परत पुढचे 5 पहिल्या, दुसरे 5 दुसऱ्या, like that onwards till that process will be get completed. So this is called the time slice. So time slice concept is available in case of time sharing operating system. So if the time slice is over or expired, so again it goes to the ready queue to get the to acquire the next time slice. Or some of the process they may create the child process. So right now it is executing on the processor and it want to create the child process. So it executes the core system call and creates the child process. So child executes. So majorly in case of system, in case of real-time system as well as in case of operating system, so mostly parents they are creating child and they are allowing child to execute first, and after execution of child they resume their execution. म्हणजे नॉर्मली कसं असतं, मोस्टली द कन्सेप्ट ऑफ पॅरेंट चाइल्ड प्रोसेस इज अवेलेबल इन केस ऑफ युनिक्स. मोस्टली पॅरेंट प्रोसेस काय करत असते, पहिल्यांदा ती स्वतः एक्झिक्यूट होते. So after execution, not whole execution, part of its own execution will be over, then it creates the child process. So gives processor from it to the child process, executes the child process, and again takes CPU back to it and executes the remaining part of the parent. So that is nothing but from CPU. So right now child process is on the CPU. So it has created child process. Sorry, parent process is on CPU. It has executed some part of it, then creates the child. After creation of child, switches the processor from itself to the child, executes the child, and again it goes to the ready state. And from the ready state again comes to the CPU, like that. Or some of the processes, they are waiting for an interrupt. So they are treated as a lower priority process. So their execution was going on processor, but due to this higher priority process, they are waiting. So they wait for the interrupt. Interrupt occurs. Interrupt will be executed. Again, they are going to the ready state, ready queue, and from ready queue again they are coming on to the CPU. So this is called as a queuing diagram. Represents queues, resources, flow. So how the processes will be get executed? Either the process will be going from ready queue to the directly CPU and directly for termination, or it will do IO request, or it is waiting for the next time slice, or it is trying to create the child process, or it is waiting for the higher priority process called as a interrupt. And again, after all these events, it is coming back to the ready queue, and from the ready queue, once again it will be rescheduled for the processor. I am using the word rescheduled. So already it has scheduled for processor, but due to this event, it is get rescheduled. So like that, one process may be rescheduled for more than one times, or one of the process may executes only once on the processor and goes for termination. So like that, this is the concept of scheduling, queuing diagram, which shows the process scheduling. Okay. So yes, students, are you getting my point? Hello.
Yes.
Yes, ma'am.
Okay, so here right now we'll stop. Actually, I have just discussed the concept of process scheduling right now. So once again, we'll revise in the next lecture, and I will tell you, or I will allow you to note it down. So we'll stop here right now. So today very little time is there. So better I will take the photos of your attendance, and then I will terminate. Just wait. Actually, your record of attendance is also created, but it is taking too much time to mark your attendance. So that's why we have to follow some other processes. Okay. Okay, thank you. We'll stop here.
We can lift.
Okay, you can do.